So the LeetCode problem we are going to solve today is called partition labels, and we can see that this one is a pretty popular LeetCode problem. Basically, we are given a string that we want to partition into as many parts as possible so that every single letter in each of the partition appears at most at one and not in any other partition. Now note that the partition is done such that after concatenating all the parts in order, the resulting string would be string S. So we cannot just partition randomly from the middle of the string. It has to be sequential. Now let's try to understand it with some examples. Let's say that we are given a scenario like this. Now we want to create maximum partition where every single character only appears in just one partition. So in this case, we can create a partition with this A, B, A, because remember A appears over here and A appears over here. So they both has to be in the same partition. And then we can create one more partition called D, and notice that if we combine this ABAD, then we would get the resulting string S. Same way for this one, we can create a partition AA because that would fulfill that all the characters of A are present. Then we can create a partition called BCDB because B is present over here and here, so it has to be part of the same partition. Now for this third one, we can create a partition AA. We can also create a partition CC, and then we would be creating an individual partition called B, and then there would be a partition called D. And this is what we need to return. So basically in the answer, we don't need to return something like this, the exact partitions, but we only need to return the size of those partitions. So for this example, we would return answers such as 2 and then 2 and then 1 and 1. So these are going to be the sizes. Now the brute force solution is actually quite straightforward. We simply take a character, we iterate over every single remaining values, we see that what is the last point where the character occurs, and then tries to create a partition of that size, and we keep on repeating the same process again and again for every single remaining characters, and so on and so forth. Eventually we would get all the necessary partitions. But the thing is, this is not the most optimal approach, and we can see that this one would run in big O of n square time, so we can do something better. And let's try to find an easy and simplest solution that we can derive from originally brainstorming our brute force approach, and that is to use the greedy way to solve this problem. We are going to be very efficient in picking and choosing how we are going to go forward by selecting the partition. Now the first rule to select any particular partition is to identify that for any particular character, the starting value doesn't matter, but what is going to be the last occurrence for that particular character matters the most. Because once we identify that a character is part of any partition, then we will have to figure out that what is going to be the last place this character is going to be placed at. That is number one thing. Second thing is, apart from being like finding the last position, we would also have to figure out that this partition makes sense if all the characters present in this particular partition has the last point either being this value or before that. I repeat that this can only be a partition if every single unique character that there are present, their last point or the last occurrence would either be less than the index value that we are currently at. So based on using these two values and some additional variables like the partition end time and the partition starting variable, we can actually solve this problem very easily and very efficiently. So let's first identify our first approach, that is to find the last occurrence for every single unique character. So let's say that for A, the last occurrence is going to be index number 2. For B, the last occurrence is going to be index position number 1. Okay, so now we have our list of last occurrences for every single character. After that, we can start iterating over any particular given character in this simple fashion in this given string, and all we will have to compare is that what is going to be the last occurrence compared to its current ith position, and whichever is going to be the greater value, we are going to put it as part of our partition end, because that has to be the partition end, and whenever we find a greater value, we would update the partition end that we are currently at. On top of it, if we are at a position where the given ith value is equal to the partition end, which means we found out a correct partition. So no other character exists that has a greater last occurrence compared to our current value, and we can mark it as a partition. So we can just add it to our result list. So let's say that we are also creating a result list to store all the results. Okay. and let's just follow our approach. So first we identified value number A. So for value number A, the last occurrence is located at position number 2. So the partition end has to be at least value 2. So we'll mark it over here. Okay. And then the partition start initially is going to be 0. Then we are going to iterate over value number B. What is the partition end? Partition end is 1. 1 is lesser than value number 2. So which means we don't need to update the partition end. Next current ith value we are at is value number A, that is located at position number 2. So in this case, because I is equal to 2 and the partition end is also going to be 2, we can actually mark these values inside the result. So currently in the result we are going to have 3 characters, so that we can determine by finding out position start minus position end minus position start plus 1. We'll have to add plus 1 because we are starting with a 0 index. So in this case, first result is going to be value number 3. After that, we are going to update the position start value to the partition 3 number 3, and we are going to reset the value of partition end. Okay, so currently the partition end would be dependent on this particular value C. Okay, so C for the current C value, the last occurrence is 6 and previous value was 2, but 6 is greater, so we are going to mark 6 as the current partition end. Now for this D, the partition end is going to be 4. So 4 is lesser than 6, so we don't need to do anything over here. Same way 5 is lesser than 6, so we don't need to do anything over here. Now we are at I is equal to 6 and current partition end ends at 6 as well. So in this case, once again we are going to do partition end minus partition start plus 1. So we will have 4 characters in this second partition as well, which are these 4 characters. Now we are at value now the new partition end is going to be value number 7. Okay, so we mark partition value number 7, and lucky for us, the value we are iterating over for Y is also valued at value number 7. And by the way, the partition start would also be updated to value number 7. So since we found I is equal to 7 and the partition ending position is also 7, so we can mark this as a new partition, and this is only going to contain one element, and same way this is also going to contain one more element, and we can mark it as the answer. And this is the whole solution basically. Let's do a quick recap. First, we created an array that is going to store the last occurrences of every single character. Once we have that, then we can simply go over all of these characters one by one, comparing with the last occurrence, the current position end date and position start value, and we can maintain a result array. And if you see the coding solution, this would become much more sense that how does all of this operates. Now if we calculate the time and space complexity, in this case the time complexity is going to be big O of n, because we will have to iterate over the given input string couple of times, but overall it's just a linear update or the linear traversal. And the space complexity is also going to be big O of n, or this can be big O of 1 depending on how you perceive it, because if we are only talking about the lowercase English letters, then there are only 26 possibilities, and we can use a constant amount of space to solve this problem. So you can debate this with your interviewer on how they wants to perceive it, but basically both the approaches would be correct. So the coding solution is going to be quite straightforward. First, we are going to check that what is the last occurrence of every single character, and since there are only 26 characters that could be in string S, we can use a simple array instead of using a hash map. We can iterate over every single characters and then just mark their position with the appropriate ith position and just store it in our array called last occurrence. Step 2 is to iterate through the string and determine the partition. For that, we will need to have a variable to store the answer, and we are going to initialize our array list called result. We also need a couple of variables to keep track of the partition end and partition start pointers. So once we have everything set, we are simply going to iterate over the given integer, and we are going to mark the current partition end as the maximum value between the current partition end that we have been able to find and the maximum value of the last occurrence of the current character we are at. Then if at any given point we identify that the given I is actually equal to partition end, then we can simply find we have simply found a partition where there does not exist any more characters further than that point. So we can add that value to the result, and then we can start working with our next partition. So we can just update the value of the partition start, and then we can keep on repeating the same process, and in the end we can simply return our result array list. So let's try to run this code. So the solution is working as expected. Let's submit this code. And our code beats 91% of all the other solutions, which is excellent. And I would be posting this in the comments, so you can go and check it out from there. Thank you.